can post your comments, and our colleagues will try to, throughout the webinar, to answer those, and we can bring those up during the discussion. Please, at the end, when we have our panelists, that's when the open discussion is. I'd like you to put your hand up so that I will be able to enable to your audio, and you should be able to speak then. If you are joining by phone, please join with a personal link name to add your name so we know who to call if you raise your virtual hand. Next slide, please. So today we will be focused on a low-cost, replicable approach for data identification and mapping of ecosystem extent, developed through a partnership between the US Space Agency, NASA, Conservation International, and the government of Liberia. The proposed approach here of mapping ecosystem classes seeks to contribute to overcome, which is often a hurdle for or an obstacle towards the implementation of ecosystem accounts by many countries. Next, the agenda of our seminar will include 3 keynote speakers, very brief presentations. We'll have a video also documenting the mapping exercise, very briefly synthesizing the approach, and then we'll follow up with a panel of experts, and then after that, Q&A with webinar participants. And before we start, I'd like to highlight the remarkable achievement of the adoption of the sea ecosystem accounting as international standard just a few weeks ago, and extend my congratulations to the UN Statistic Division, Alessandra Alfieri and her team, as well as the community of experts that worked over the last 3 years to make that happen. So we are incredibly happy with that accomplishment. We know that currently about 34 countries are compiling ecosystem accounts, and we are very reassured that the adoption of the standards will be a major step forward towards global adoption of accounting for natural capital. So we now move to our keynote speech for the webinar. May I ask whether, Danielle, whether we have been able to get Mr. Wapo from Liberia?
I'm not sure. Berexford and Mr. Wapo, are you on the line? I don't see them as attendees. I think they're still having trouble dialing in.
Okay, so in the interest of time, Danielle, may I ask you to start our webinar with a keynote speech, and we'll certainly hope that Mr. Wapo will be able to join us shortly.
Certainly, Rosemary. Mira, could you advance the slide to the second presentation, please? Okay, great. Well, thank you, Rosemary, and good morning, good afternoon, good evening, everyone. My name is Daniel Jun. I'm with the Science Unit of Conservation International, and I also have the great pleasure to work with the Earth Observation for Ecosystem Accounting Initiative of the Group on Earth Observations. Thanks to the organizers for the opportunity to speak with you today. And I'm sort of a bridge between Mr. Wapo's presentation on the policy context, and hopefully they'll be able to resolve their technical difficulties soon, and bridging that with the presentation that'll take place next on the results from Liberia. So I'll spend the next 10 minutes providing a brief overview of ecosystem accounting, the role of Earth observations, and a few short words on the CI-NASA partnership. Next slide, please. So I'll start by quickly reiterating the problem statement that I think we're all acutely aware of. And this is the first presentation I've given since the release of the Dasgupta report on the economics of biodiversity, which is an incredible synthesis on the subject. And so as a poor summary for the 600 pages in that report, we know that nature is foundational to the prosperity and security of people and economies. but we're not properly valuing nature, and thus we're losing the natural capital that humans depend on. So ecosystem services, as sort of crudely illustrated here, are those benefits to people from ecosystems. So for example, forests that mitigate climate change and harbor biodiversity, rivers and wetlands that provide fresh water and drinking and energy production, or mangroves that provide fish and support food security. So these benefits from nature are hidden, as are many of the impacts on nature. And in short, we're ignoring the natural capital in our economic measures, policy, and planning. Next slide, please. So in the Dasgupta report, they have some interesting statistics and findings. Between 1992 and 2014, the produced capital per person doubled while the stock of natural capital per person declined by nearly 40%. And I think the report mentioned something like we need 1.6 Earths to sustain ourselves at our current trajectory. So this is a systems level problem. And as the Dasgupta report highlights, we have to move to another economic model that does not ignore nature. And it's a matter of some urgency. So natural capital must become central to our global economic decision-making. And if not, the risk is that our natural asset base that underpins the global economy will erode to the point of collapse. Next slide, please. Next click, please. And so the good news is that there's recognition of this. And the recognition is not just technocratic or academic. It's a real recognition from, in the case of Africa, presidents and ministers, as evidenced and expressed by the 14 countries committed to natural capital accounting as a pathway to sustainable development. Through the signing of the Gaborone Declaration of Sustainability in Africa in 2012, long before the Dasgupta review. Next slide, please. And many of us here today helped forge that Gaborone Declaration for Sustainability in Africa. And I'm sure you were as delighted as I was to see that one of the key solutions in the report, in the Dasgupta report, was natural capital accounting. So we're broadly familiar with natural capital accounting, so I won't read off this slide. We know that it's a systematic process for valuing nature and linking that with our national accounts. And I want to note a great analogy from Jim Boyd, who's an economist at Resources for the Future. And he wrote a very elegant piece on natural capital accounting. And he explained that as early as 1930, which is less than 100 years ago, not that long ago, really, to know the state of the US economy, you would need to count train boxcars traveling between New York and Chicago. Or to understand unemployment, you need to count people in the bread lines and the unemployment lines. And so he argues that we're at that same rudimentary stage today with respect to our natural economy. The environmental goods and services we don't pay for that make all economic activity possible are just not systematically measured. And we still act on that impressionistic view of nature that doesn't allow for measures that allow for diagnosis or even prediction and cure. And so this is the essential, this is the rationale for accounting. And the ambition for us is to stop the equivalent of counting boxcars and provide governments and businesses and communities with those tools to mainstream nature's values into decision-making processes. Next slide. And so the good news is that we are on that road. This is just a brief overview of the SIA, which is the statistical framework to measure the environment and interactions with the economy. There are two complementary frameworks and approaches aligned with a system of national accounts, which is used to generate things like GDP. And so on the left, we have the central framework, which focuses on natural resources as an economic value, as an asset, I should say. And the key focus is really change in stocks of individual and environmental assets and the flows between the economy and the environment, such as mineral, fish, water, timber, soil, things like that. And that's really an achievement, but there was a recognition we need to go further. And thus we have on the right side, ecosystem accounts, and that focuses on ecosystems as an asset and by evaluating their extent, their condition, and the flows of benefits. To do this, you need spatial data and hence the link with Earth observation, which I'll talk about in a second. And Rosemary highlighted the major milestone last month when the SIA ecosystem accounts joined the central framework and became an international statistical standard. And many of you here have driven the policy need for it, supported it, contributed to it. And so a big round of congratulations, not only to the SIA, but to this community for this landmark moment. And so now we essentially have the global standard for natural capital accounting and translating the language of nature into that of the economy so the two can talk to each other. Next slide, please. And today in this webinar, we'll focus on the ecosystem accounts side of things and the work that we've done together with the government of Liberia and NASA. I do just want to quickly go over the ecosystem accounts. I think we're broadly familiar with this, but we have extent, which looks at the extent of ecosystems, the quantity and where those ecosystems are, and conditions, which is a measurement of ecosystem health. And then we move to looking at the ecosystem services and the benefits, which are the ecosystem services, right? Those are essentially the components of ecosystem accounts. And so each box is essentially an account, and in their own right, they provide information for decisions that are important to us, such as the status and health of ecosystems over time, or the trends in the capacity of those ecosystems to provide those benefits and how that might be changing, understanding the drivers and actors of change in the environment. But those accounts together, particularly if you look at trends over time, provide amazing tools and presumably insight for policy and decision-making for, say, development planning. And the idea is to have more quantitative information for the design of policy or for environmental regulations or the design of natural resources management strategies. We could evaluate or test the impact of our economic policies on the environment and vice versa, and provide indicators in the environment and the economy in some coherent and integrated way. And that's important because some of the indicators possible with the SIA, say extent, for example, are those suggested that the countries monitor for their multilateral environmental agreements that they've signed on to. And there's some discussion of having SIA as being a big part of the monitoring for the global biodiversity framework. And from my perspective, that would be a tremendously important outcome. But I did want to point out that ecosystem accounting is inherently spatial and relies on spatial inputs. And because of that spatial nature, it has easy links with policy. So each box has this Earth observation component, and extent, which Celio will speak about in a second, is that critical mother account. Next slide, please. And Rosemary quickly pointed this out, but just wanted to show the progress of SIA ecosystem accounting. This is perhaps an outdated slide, but all that to say that now that the standards are international standards, now that ecosystem accounting are international standards, we can anticipate more. I think some 90 countries have expressed interest in SIA accounting, and it's our collective hope that sub-Saharan Africa will populate this map in the future, and that's what we're here to discuss. Next slide, please. So just a brief word, condensing 6 slides into one on Earth observation towards ecosystem accounting. So because the ecosystem accounts rely on spatial inputs, Earth observation obviously plays a significant role. And I'm pretty excited about this, but we recognize the challenges. So on one hand, there's great advances in Earth observation availability and technology that make the assessments to generate the accounts doable and very cost effective. On the other hand, it could be challenged for national statistics offices, the NSOs, who are more geared to being producers rather than users, right? And an insight that I got from Francois Soulard, who is from Statistics Canada, and who has experimented quite a bit working with Earth observation data from the NSO point of view, working with their government counterparts responsible for mapping, NSOs need to adapt in order to develop those processes and those methodologies to properly interpret existing Earth observation data sets. And so there's a challenge that we face there. There are many data methods, tools that allow for scalability and comparability that can meet the needs of accounting. And that's an amazing advance. But on the other hand, the Earth observation assets at our disposal are not yet designed for official statistics. And we want to reach a state where we're integrating statistics objectives into our Earth observation processes from the very beginning. Global data, it's an important and incredible resource, and it offers a consistent and repeatable basis for national or global comparisons or for tracking changes over time. The methods are published and scientifically solid, and they can often give a country a head start with some initial analyses. But of course, scaled down data is often what we need, and it's challenging to users to generate that from scratch. So that's another challenge that we face. And lastly, there's just a lot of it out there. There's a lot of Earth observation products out there, and it's difficult to make sense of all of those products. So, in the past minute, this is just a very, very coarse overview of the promise and some of the challenges and barriers in Earth observation. But in short, we have some work to do to bring this work up to scale. Next slide. So with this in mind, that's kind of where the community is heading, right? Now that the SIA is our statistical standard, the community recognizes those challenges and is moving towards them. The SIA is made possible because it brought together statisticians, accountants, ecologists, geographers together. And it's vital that we continue that trend of bringing the geospatial community together with the accounting community. And that's part of the rationale of the Earth Observation for Ecosystem Accounting initiative from the group on Earth observation is to really merge those communities together to look at this issue. We're looking at the notion of ecosystem account ready data, which are derived from Earth observation and can be readily applied to national statistics within an accounting framework. And so I think that's going to be an important condition moving forward. Some of the work on the horizon for data producers and curators is to develop platforms to generate information that's relevant and readily usable by NSOs for ecosystem accounting. And so efforts I'd like to call out include things like UN Big Data, who's been doing a lot of thinking about this, the Aries platform out of Bilbao and Ken Backstad and Fernando Villa's work, as well as that of the UN SIA, which is helping to develop that Aries platform. The group on Earth observation, which recognizes this work as a priority by forming EO4EA, and the European Space Agency and NASA. And on that latter note, hence the CI and NASA partnership. Next slide, please. So
Danielle,
yes.
may I ask you to please wrap up?
Oh yes, I just have one more minute, Rosemary, thank you. So the CI NASA partnership, the long-term goal is to develop decision-making tools and practices, right? NASA brings quite a bit of scientific expertise and legitimacy from decades of Earth observation and their arsenal of satellites. The sort of medium-term goal is to support the GDSA countries by providing tools and approaches to advance Earth observation for natural capital accounting. And the work that we're going to talk about today is to develop a low-cost and replicable approach and tools for countries to use for ecosystem extent mapping. And so just a brief summary of the CI-NASA partnership and the rationale. Next slide, please. So thank you. Sorry for being so short on some important issues revolving Earth observation and ecosystem accounting. One of the things we're thinking about is giving a webinar to this community of practice on EO4EA specifically. So if there's interest in this subject, we can certainly expound on that. But if you have any questions, let Max Wright and I know. That's our email address, and do contact us. So thank you very much, and thank you for your attention. Over to you, Rosemary.
Thank you so much, Danielle. This was incredibly rich and informative presentation. In some ways, it really provides context to everything else that we need to do tonight, and it all works out very well. I'm very glad to introduce our next keynote speaker, and that's Mr. Elijah Wapo from the Environmental Protection Agency of Liberia. Mr. Wapo is the overall lead person at EPA in response to collaborate with relevant line ministries, agencies, and to ensure integration of environmental issues into National Development Plan. So he is also the national focal point for natural capital accounting implementation in Liberia. And we are very much delighted to have Mr. Wapo to talk about his experiences and to address the issue of how accounting can inform policy and decision-making in the context of a developing country, in the context of Liberia. Over to you, Mr. Wapo.
Thank you. Hello. Certainly, I want to welcome everybody. I'm very grateful and honored to be here today to discuss our ongoing efforts to implement SIA, that system of environmental economic accounting in Liberia, specifically on the effort to map ecosystem classes toward that goal. So we want to say thank you. Next slide. So Liberia is a country on the west coast of Africa. It has 43 square meter. That is the area of 111,369 square kilometer. Liberia hosts some of the best West Africa large intact forests and one of the continent's best remaining habitat for threatening species such as the western chimpanzee, the forest elephant, the pygmy hippo. Liberia is also densely populated, less densely populated. So it makes Liberia a very unique country when it comes to conservation, unparalleled to any country in the sub-region and in the region. But Liberia is, the people of Liberia are poor and they suffer from an extremely high level of food insecurity. The indicator shows close to 70% of Liberians live on the poverty line. And over 70% of the country population is dependent on forests for their food, their livelihood, and so forth. Bushmeat is still one of those issues that are of concern. And they use that for protein and for many people in a rural area. And then along the coastal line, fishery provide protein and income for a large population of the Liberian people, shrimp, crabs, and so forth. And these are what they use for protein. They also stabilize the coastline, reducing erosion and slowing flood waters. Liberia's government is searching for a way to meet the food security, income, and so forth. So, impetus of our national development plan, the role of natural capital accounting, plays an important role to help us realize this. We'll be looking at this. Next slide, please. Yeah. So,
sorry, could I just ask Miro to try to get that black box out of the way? Thanks, Miro. Sorry, Laya, please go.
Okay. So the government of Liberia instituted the PROPO agenda. They adopted this JEF NCA Pro document. This PROPO agenda for prosperity and development is the Liberian government primary strategy to foster sustainable and equitable growth. This strategy seeks to promote sustainable, transparent, and well-managed use of Liberian natural resources. Like most government, especially so in the region, they adhere to the statistical standard of the UN system of national accounts. But the SNA is not adequate enough to help government to provide information so as to make informed decisions. The way forward is to include the SIA or natural capital accounting in our development program so that it helps us to make holistic, informed economic and social development decisions for sustainable growth. Incorporating natural capital into national accounts in Liberia will reveal the impacts and dependencies of economic activity on the environment and support a better economic decision, as I mentioned earlier. By providing information on the true cost of natural resource use, depletion, area degradation, NCA can help a country like Liberia decision makers to better understand the impacts and trade of our development decisions. Next slide. Mapping essential natural capital in Liberia is very essential. Sometimes in 2016, a team of scientists, I must be very grateful, and staff from the Conservation International and the government of Liberia concluded a pilot project to identify and map which ecosystems are essential for sustaining human and well-being of the economic activity in the country. So key finding, most essential natural capital stay at intact, but mostly unprotected and management of strategic needed or a more sustainable development. And we are very happy that CI and NASA was able to do the map for us as a country, and the map have been endorsed. What the EP and the Liberian government is doing now is to ensure that the map is available in all sector ministry and agency for informed decision making. With some key findings that were included in the area to protect generated a range of maps showing the highest level of essential natural capital. Most essential natural capital for biodiversity, carbon and freshwater ecosystem services in Liberia is still intact. A multitude of management strategies are needed to ensure the flow of benefits from natural capital is sustained. So conservation agreement, sustainable production, and community-based management supportive, for example, is essential. With the high reliance on our people and ecosystem for the well-being of the country is important. Outcome of this effort was the recognition of the government of Liberia of the system. Next slide. Like I mentioned, CI and NASA, the government of Liberia ecosystem extend map, the CI complying is a big boost to us. We have various land cover and forest cover maps. Both to embark on this, we knew we needed to begin with identifying our ecosystem. We needed to do classification and to update map of ecosystem distribution at a national scale. So we partnered with NASA and CI, and this was done, like I mentioned, it was launched, and the government of Liberia appreciate its partner NASA and CI so very much for it. And it's going to be made available in all land ministry and agency. The approach generates information on land cover and ecosystem distribution, enabling the implementation of both land and extend accounts from 2002 to 2018. And I'm delighted to let you know that EPA accept this, and the government of Liberia have endorsed it, and we use it. I want to commend our partners for this. Next slide. The Jeff Ecosystem Natural Capital Account Project, the next phase for the accounting in Liberia, we now move to the next phase of this process by getting involved with the Jeff funded project, conservation and sustainable use of Liberia coastal natural capital, which launched its summer of the Jeff NCA. We will use this to implement the ecosystem accounting in coastal ecosystem, develop a way to facilitate scaling up the entire country, identify innovative financing scheme for the conservation and management of ecosystem services, implement community incentives for community, improving livelihood and reducing the vulnerability of men living in coastal areas. It will also help us to build our capacity within my agency like EPA and others to ensure that these approaches and methods will continue beyond the life of this project. Next slide, please. Supporting the goal of protecting about 30% of its territory. And currently in Liberia, there are 5 protected areas and about 9 proposed protected areas. When you sum this up, it's going to help us to meet up with the requirement of setting aside 30% as mentioned in the 2006 Forest Reforms Law. Cross-sectorial planning will be enhanced, impact assessment, sitting on intervention, climate change, adaptation, spatial planning, etc. Supporting multilateral environmental agreement that supports sustainable development goal, post-20 biodiversity framework, and the issue of our NDC will be enhanced. Next slide, please. As previously mentioned, we see the implementation of SIA, the ecosystem account, as a means to support Liberia's long-term sustainability and green growth, while alleviating poverty and human well-being toward achieving objectives of the Pro agenda, the PAPD. And what it is, like once upon a time, it want to help the decision maker to ensure that decisions are economically balanced for the benefit of the Liberian people. It will support the design, planning, and monitoring of NDC targets, activity and indicator, and measuring co-benefit of human well-being. And one public authority said that when we presented a bit of what the benefit would be on natural capital accounting and the benefit would derive, say, oh, we didn't know this. Strangulating the support for EP have been our problem because we never had this information. So this is going to help us and our decision maker a lot. Please, next slide. What's the way forward? Now, the maps, the land, and the extent account generated through this partnership are an important step forward in informing policy and decision making in Liberia, like I mentioned. Environmental Protection Agency is committed to foster the development, the information, the data, the knowledge management sharing, and the monitoring and the reporting requirement will be enhanced. Like we have the environmental, EKMS environmental knowledge management platform. This is going to be running parallel to this. It's going to help with multi-agency coordination along with LEGI, Forestry Development Authority, Land Authority, Maritime, Ministry of Mines and Energy, and so forth. And this is going to help us with our country development making. And it will be holistic in that we'll not only be taking decisions from the SNA, but this will inform national development planning and help with our relationship with the global world. Next slide. Next slide, please. We want to say thank you. We would like to thank the Africa NCA Corp for the opportunity to present our ongoing efforts, and we'll welcome a discussion on how our efforts can support similar intervention across Africa, and in line with our commitment to incorporate the value of natural capital in public and private policy and decision making as per the GDSA and consistent with our national development agenda. Thank you.
Thank you, Mr. Wapo. Thank you for, an inspiring presentation and, very clear and concrete examples of how this work and ecosystem accounting at large will support development planning, especially with respect to the Pro agenda goals of sustainability, green growth, and poverty alleviation. We are all very inspired by your leadership and example. Now we move on to our next phase of our presentation, which is a little bit more technical and provides a little bit more of the details. Before we do so, Miro, can I ask you to please take a look at the slides again and see if you can address the bar that is blocking the view? Some of the participants are asking about it. In any case, as you do that, I will bring Dr. Temilola Fantoyimba from the NASA Space Agency. She is a research physical scientist in the Biospheric Science Lab at NASA Goddard Space Flight Center. And she studies forest ecology and ecosystem structure using active and passive remote sensing instruments. Lola serves on satellite mission science teams and is principal investigator on several NASA Earth Division funded research grants. So Lola, the floor is yours to introduce the video that will follow up. Thank you.
Thank you, Rosemary. And thank you to everyone who is here. It is great to have you here today in this webinar. And I'd like to introduce this video that was made between NASA and Conservation International, highlighting the work that was done between the two groups in support of the natural capital accounting work that is being done in Liberia. I would like to stress that a lot of the work that was done has been really spearheaded and encouraged by the government of Liberia, and we'd like to thank everyone who was involved. And with that, please go ahead.
Liberia is an incredibly biodiverse country. The ecosystems, like its forests and mangroves, have an impact on the country's economic plans, and as a result, people's livelihoods and the environment. I'm part of the NASA's technical team under the partnership with Conservation International. NASA's role here is actually to provide the expertise and the technical experience in remote sensing and Earth observation that it has as an institution. So part of my job is actually to leverage all this knowledge and experience and data sets and different technologies that we have available through NASA to provide these nations with up-to-date, accurate, high-resolution land cover maps. This is important because the first step of ecosystem accounting is to actually map the dynamics of ecosystems over time. And we also must verify and compile biodiversity information with these land cover maps to get a complete picture of ecosystems and their benefits.
Conservation International is working closely in this partnership with NASA to ultimately develop this first ever ecosystem map for Liberia. There's really two work streams that are coming together, and NASA has been leading the development of a land cover map, and CI has been leading the development of a map of potential ecosystem types, because this really didn't yet exist for Liberia. When we're talking about these benefits, we're referring to natural capital, which is really the stocks of these natural resources. And that's estimated to be even more than half of the total wealth in countries such as Liberia. So there's really a desperate need for a more cost-effective and replicable approach to assess what this wealth is coming from natural ecosystems. And the first step to do that is to combine where we expect these potential ecosystems to occur with the actual known land cover that NASA has produced to come up with that final map of ecosystem extent. Because it's those differences in ecosystem types that are providing those different benefits, and we need to know where those are spatially so that we can begin to understand how much and from where those benefits are coming, so that we can then make decisions about how to protect them and maintain those flows of benefits into the future.
We are producing and offering these countries the tools that they need to actually start accounting for their ecosystems and their ecosystem services and bringing this information into their decision making at a national level. So this will ultimately translate into better policies for conservation, and that will bring essentially benefits for their economy and the society in general.
So if we can regularly update these accounts over time, then we can really understand those trends in how nature is contributing to the economy and to human well-being, and we can use that information to make better decisions about how we can protect those ecosystems and maintain the flows of those benefits that people need.
The government of Liberia formally adopted this map as the basis for the national system of ecosystem accounting. So it is a huge deal for us because this map will essentially serve as the starting point for them, not only for ecosystem accounting, but for other conservation and planning efforts as well.
Thank you. Thank you very much. I now have the privilege and the honor to bring Dr. Cílio de Souza, who will talk a little bit more in detail about some of the technical elements associated with the development of the maps and the land and extent accounts. Cílio, the floor is yours. Can we bring his presentation, please? Thank you.
Thanks, everyone. First of all, big thanks to the organizers for this event. This has been a great webinar so far, and it is a pleasure for me to be here representing our NASA team. My name is Cílio de Souza, and today I'll be talking about the use of Earth observation data to generate ecosystem extent maps and looking at what we have accomplished so far for Liberia. Next slide, please. All right, so I want to start by saying that Earth observation satellites are always watching our planet from space 24/7. So there is a multitude of different instruments up there that are designed to highlight or investigate a particular feature or phenomenon back here in the planet. And here I brought just a tiny little sample of the types of instruments that are currently orbiting our planet as we speak. And there are satellites up there that are working to improve our weather forecast. There are satellites up there studying CO2 concentration in the atmosphere, for example. There are others designed for collecting those very high resolution imagery that we see on Google Earth, for example. But in the context of this project, we actually must highlight a particular mission, the Landsat mission. So Landsat satellites have been collecting data about the surface of our planet for almost 40 years now. And it really does help us produce maps with great completeness over large areas of land in our planet, which would be almost impossible if we were to use airborne sensors, for example, like airplanes. So Landsat data is a great asset if you are aiming to produce land cover maps, because its data is reliable, has been used for years in land cover land use research and global change. And we have a vast amount of historical data available to us. Next slide, please. But how do we transform this Landsat data into maps? By using what we call image classification. So image classification is essentially assigning a class, or in our case here, a land cover class to the pixel. And pixel is the smallest mapping unit from the Landsat data, and it represents 30 by 30 meters on the ground. And how do we do that? As I mentioned, a Landsat collects data from the surface of the Earth, and the nature of this data is purely spectral, meaning how the surface of the Earth is actually interacting with the energy coming from the sun. And the Landsat sensor detects that. So each feature in the surface of the planet, or in our case here, each land cover or ecosystem class, will have a particular spectral signature or a spectral ID, if you will, almost as if they would have a spectral footprint or a fingerprint. And then we use special algorithms and classifiers to learn about these different fingerprints, and they help us to find other pixels with similar characteristics and similar fingerprints, and then label them as a given land cover class. This is how we transform the spectral and Landsat data into a land cover map. Next slide. Now, how did we produce those maps that we just saw in the video a few minutes ago? This was a joint effort between NASA and Conservation International. And here I show an overview of the 2 work streams that ultimately led to the final ecosystem extent map. So on the NASA side, we focused primarily on the land cover mapping. And to achieve that, we took advantage of the Landsat data that I mentioned previously. And also we took advantage of other data sets that would potentially assist us to identify different land cover classes in Liberia. And remember about the special algorithms and classifiers I talked about? One of them is actually called Random Forest, and we can use it through a platform called Google Earth Engine, which I'll be explaining a little bit more later. So in the end, you end up with a land cover map. On the Conservation International side, they focus on different data sets, but some of them actually can be also derived directly or indirectly from all those sensors orbiting our planet. So in that case, they use species distribution data sets and also biogeophysical data sets, such as rainfall. They also use air temperature data sets, soil and topography as inputs to a generalized similarity modeling approach, or as we call it, GDM. So the GDM here is a technique that will use all this different information, all these different data sets to predict plant similarity within the area of study, which in this case is the country of Liberia. And then we'll transform this information into a discrete map with broad types of ecosystems. And now we have 2 maps, a land cover map and a broad ecosystem class map. And finally, we merge those 2 together to achieve the final ecosystem extent map. Next slide, please. And what are the benefits and advantages of using this approach? Well, on top of the fact that we are using state-of-the-art algorithms and the techniques that I mentioned on both of our work streams, there are also advantages that are directly related to the platform that we are using to achieve or create those maps. And on the NASA side, we are relying on Google Earth Engine. Google Earth Engine is an online platform that was designed to actually speed up remote sensing analysis and is actually changing how we make land cover classification because it's super fast, it's very reliable, and it's very easy to operate. And on the other hand, we have R, which is one of the most used statistical analysis package there is. And but how does these advantages translate into reality? What is the tangible advantages of all these technicalities about these platforms? Well, it means that it is very inexpensive. So it's very cheap, it's very low cost. Both Google Earth Engine and R are free, so you don't need to pay for them. And also you won't need an expensive computer and an expensive suite of softwares to be able to handle all the Landsat data sets and run the analysis, because Google Earth Engine does this for you in a matter of minutes. And now, since we are using one platform and not using several softwares and several types of computers, and these makes our approach more streamlined, since everything happens in one single place, helps to streamline our approach, which in turn makes it easy to transfer to anyone who's interested in reproducing. Plus the fact that the language used on those platforms is very standard and not very complicated to learn. And finally, since we are using the state-of-the-art techniques, we are making sure to achieve the best possible outcomes or high quality final maps. Next slide. Okay, yeah, this is the final land cover map that was created using the approach I just talked about. It's a 30-meter resolution map following the nominal resolution of the Landsat dataset that we used. Again, a mapping like this using the old traditional ways of doing so would be very cumbersome to achieve. But Google Earth Engine certainly helps with all of its processing power, and the fact that we have all the data sets and everything that we need in one place. So Google Earth Engine is actually the way that we do land cover classifications now. And Our approach yielded a high quality map with an overall accuracy of 83%. So we are very, very pleased. Next slide. And here is the plant similarity map showing 4 discrete classes of potential ecosystems in Liberia. These are the broad ecosystem classes that will bring more detail to the land cover classes that we just created. Next slide. And as I mentioned before, the final ecosystem map will be a product of merging the land cover map and the broad ecosystem classes. And we developed a very simple way of merging those 2 maps, which also adds to the advantage of our approach. So this merging brings the final map to a count of 22 classes of ecosystems, including some land uses as well. And yeah, this is the star map of the video we just watched because it is the first of its kind for Liberia, and we are very excited about it. Next slide, please. And for the future directions and the next steps we're taking, we want to start sharing this knowledge and this new way of creating ecosystem extent maps with the countries that we are working with. So we documented all the steps that we have taken, and we compiled a few introductory exercises to get people acquainted with Google Earth Engine. And right now we are working to improve and expand this material into a full training course where people can essentially learn how to do the full analysis from the very first steps of getting the Landsat data to have a map of ecosystem classes. And we're very excited about it. Yeah, I think this is it for me. Next slide, Mira. Thanks everyone for your attention. I know this is a very quick overview of the methods, but if you're interested, happy to discuss. Thank you so much.
Thank you so much, Celio. This is incredibly informative and very clear. It seems to me that you managed to talk about something so complex in such a short amount of time. And really, it seems to me that it's also, you know, very impressive and very promising, as you suggest. So it's great also to hear your thoughts on the future directions and the next steps. And this is something that we can also address now that we bring the panelists for a very short round of questions to address some of those issues. I'm gonna bring back Mr. Elijah Wapo from the Liberia Environmental Protection Agency as one of our panelists. I'm also bringing Dr. Temilola Fantoyimbo from NASA. And last but not least, I'll be bringing Miroslav Honzak, who is a senior director at Conservation International and also one of the overall lead of the work on the ecosystem classification to talk about some of the technical elements associated with those maps. So Miru, Dr. Wapo and Lola, let's start our panel discussion. And I think I'm going to start with Mr. Wapo. Mr. Wapo, can you hear me?
Oh, I'm hearing you.
Wonderful. You spoke about a few policy applications of ecosystem accounting in your presentation. Now, let me ask you something. What are you most excited about the possibilities of that an ecosystem map and an ecosystem extent accounts that have been produced can provide for planning and monitoring in Liberia?
Thank you so much. The fact that this system will give us the ability to measure progress on certain targets of our national development agenda to ensure sustainability objectives of the agenda and our responsibility to the global world is a very key excitement for us and the people of Liberia. The fact that it has the ability to ensure a multi-agency, participatory and coherent coherent ability is going to toward development and policy planning and to inform national decision-making sites or the lot. The fact that they promote the availability of environmental information, data, and knowledge sharing for monitoring is a very good initiative at Site Earth. The fact that it has the potential to utilize ecosystem benefit as a criterion to inform resource mobilization for protected areas that ensures a more effective conservation while generating improved livelihood and income for rural community give a real excitement. The potential to address cross-sectorial policy issues, thus informing impact assessment, setting up intervention as it relates to climate change adaptation, mitigation, and spatial planning is very serious excitement for us. And this helps us, in fact, this system has the potential to inform a more sustainable economic and to demonstrate the contribution of nature to our country GDP. All of these and many more that I may not be able to name now and give a real excitement, and we are grateful for this endeavor.
Thank you, Mr. Wapo. It's indeed quite impressive, the range of things and range of potential applications of this time of effort. I'd like to bring Miro now. Miro, you were the overall lead for mapping ecosystem classes. Now, let me ask you something. How applicable this approach is to other geographies, to other countries? And what are some of the minimum requirements for development of the maps by accounts as well?
Thank you very much, Rosemary. Thank you for the opportunity, for the question. And this is a very good question. And we, at the beginning of the project, we thought about it a lot. And we also studied the CI guidelines carefully. And the new CI guidelines are intentionally sort of designed in such a way that they allow flexibility of countries to actually develop their extended accounts and the maps the way that is appropriate for their national context. And this approach we developed with NASA is a way to achieve it by taking advantage of the latest development in cloud computing and an availability of free Earth observation data through that platform, and also the species data. The species data which we used for modeling of ecosystem types actually comes from a sort of a global platform that is available freely out there. This means this approach is probably relevant mostly for the countries that are starting the NCA work, that have sort of little or no information available to them. And that means, it is a good start. It obviously needs a lot of ground truths and checking with the experts in order to sort of develop the final product. And we currently are sort of applying this approach to another 2 countries in Africa with a success. And as far as the minimum requirements, as Celio mentioned, what you need is sort of a computer and a reliable connection to the internet that allows you to access the cloud computing facilities. You need to also install, the R package on the local computer and have enough memory to run the programs that we develop. So we are, as mentioned by Celio, we are developing these training materials, and these will be shared widely in near future with countries that have and would be interested in applying this approach.
Thank you, Miro. It sounds thus indeed it's very promising. Now, Lola, you have extensive experience on the use of remote sensing instruments to enhance understanding of forest and forest ecology and ecosystem structure. Let's talk about future directions. What are the most exciting developments in Earth observation that might help ease the development of those kinds of products in the future?
Yeah, thank you, Rosemary. I think there's two types of developments that I'm very excited about. The first one is new missions that are already in orbit or launched, and missions that are upcoming in the next few years. So one example is one that actually Celio showed in his presentation. The JEDI mission is an instrument that is currently on the International Space Station, and that is designed specifically for forest applications, specifically to estimate forest structure and forest biomass, or vegetation structure and biomass. But really we have a focus on forests because that's something that is, really very uncertain when you look at, when you're using a lot of the remote sensing data that we have access to now. Right now we're working primarily with two-dimensional data, but we really need to add that third dimension to get a better understanding of what the structure is of vegetation worldwide. So the JEDI mission is working on that right now, and it's collecting data, and we're working on starting to incorporate that data into some of these ecosystem accounting approaches that we're taking. There's another instrument as well that is a NASA instrument called NISAR, which is going to be launched in 2023. And this is a synthetic aperture radar instrument. So radar has the great advantage that it can be used day and night and regardless of weather. So we don't have to really worry about some of the cloudiness that is really an issue when you're working particularly in tropical countries. With the radar data, we can also do mapping, especially change mapping, and it also has a lot of applications in hydrology, water resources, and agriculture. And the beauty, of course, of all NASA data is that it's available for free. So those are kind of two of the new missions that I'm excited about, and what I think is really important also, and what maybe Celio highlighted, which is that when we're working with the satellite data, we're not just working with one data set anymore. We used to just focus on one data set and then only use that to answer our question. Now we have all of these instruments that are available to us, and we have cloud computing, and we have programming and large data processing that allows us to actually combine multiple data sets and address some of these issues and questions that we weren't able to do before. Just like, for example, making a map, making change maps and land cover maps for a whole country. A few years ago, that would have been almost impossible. And then I guess in the next thing I'm excited about is moving kind of from having experts really processing all these data sets and having, a lot of this processing is still quite complicated, even though we're using a lot of, open source data tools, getting this data out to the community and to maybe non-experts is still kind of a hurdle. And so I think that with more and more new missions and adoption of these new techniques, we'll be producing more data that can essentially be ecosystem account ready. So we're producing, someone will be making the maps, producing the data sets, or writing the code that can be run in such a way that it spits out a map or a data set that you can use. And then the actual ministries, practitioners, NGOs, anybody who needs access to it will just use the final product rather than having to do the whole remote sensing and data processing part. So I think those are the two things that I'm most excited about, is new missions and then getting access to more analysis ready data.
Thank you so much. I'd like now to ask our participants to ask questions, raise their hands. I'd like to bring Celio to this discussion as well. And we can start already with some of the questions on the Q&A. Bruno, perhaps I could bring you in. You have a very interesting question on the accuracy, and it's the change over time, the convention to transform this information into mature, moderate, and severely degraded classes, which I think speaks to the condition accounts. So perhaps you can better articulate. Bruno, are you there?
Yes, I'm here. Can you hear me?
Yes, please, go ahead.
Okay. Yeah, so yeah, it was, I think, very interesting presentations. I I think as I explained in the chat or in the Q&A, the land cover maps are definitely a very important base which I used throughout all the ecosystem accounting and the services you want to calculate thereafter. I think classification, as it was shown, is one thing, but the change, capturing the change well, is I think still a challenge, at least from a remote sensing perspective, especially going back in the early years. So I was wondering how that was tackled and if there was, how basically the accuracy was assessed on capturing this change part. That was my first question. The second one is, I found it a very interesting technique which I was not aware of to combine at least this land cover with this ecosystem maps to come to the account ecosystem type maps. I think there I was wondering how the convention was used to transform this information and this combination of information, which is again, I think, taking the change into account into this mature and the graded different classes. That were my
Thank
two
you,
questions.
Bruno.
Yeah.
So perhaps I would bring Celio and maybe Miro to that to briefly answer that question.
Celio, would you like to first go through the accuracy assessment of that you have conducted, and then I can chip in the rest.
Oh, I think Celio disconnected. He's coming back. I'll answer the question. So for the accuracy assessment between the different dates, I'm going to have to get the actual number from Celio, but I do know that he did an extensive accuracy assessment by comparing with high resolution imagery. Could you repeat the second question?
Yeah, the second question was related to the change, how the transformation was done into the account classes, like the mature, the moderate, the severely degraded classes, which are shown.
Okay. I think maybe we should keep that question for Celio because he will know more of the detail. He'll be back soon, and then we'll get back to you. Sorry about that.
Thank you.
He's connecting momentarily.
Maybe I can answer some of it as well. So Celio may have mentioned in his presentation that we first developed a base map for the year 2015. And this base map then was used, and which was the accuracy of this base map was about 83 or 86%, I can't remember exactly, but which is good at national scale. And this base map then was used through the land tender technique or methodology developed a few years back on a stack of different images from different years. And we were able to sort of develop a time series for the period of 2000-2018. So 19 sort of resultant images that can be then used for compiling the land cover account. And on the top of it, we merged it, as you saw from this presentation, with the ecosystem type map that was developed independently from species data and bioclimatic and soil and other biophysical information. And this was merged together to end up with a large proportion of classes. Now we have 3 classes for the lowland forest, actually 6 classes for the lowland forest. And, some of them are degraded moderately, some of them are severely degraded. And we made an executive decision here together with the government of Liberia that we will keep them in the classified map because it's useful at the moment. You can always collapse them into a single lowland class and attach different map to it as a condition, and how they were decided. Well, we did made again a decision that came from the ground measurements, and with our experts on the ground, we decided that such a site is degraded moderately, and such a site is degraded severely, and therefore we eventually were able to classify these three classes separately. But as I said, we can always put them together and classify it as a one class, and then use a different measure for the condition. Hopefully I answered some of the questions.
Yeah, thank you very well. I think the land number, I can understand, and also the classes. It's basically using, let's say, local knowledge to exactly define the thresholds between the different classes.
Yeah, and I would just to add maybe a little bit on, you know, how he, you know, how the validation or how the update of these maps will be were conceived here. You know, we are planning to update the land cover class map every year, so annually. Yeah? That means you will be able to see the extent of deforestation and degradation of these ecosystems, and the ecosystem type class map is actually we foresee that, you know, there is not much change because the species are not changing as fast as, for example, deforestation. Therefore, we envision that maybe this map will be revised every 10 years or when the new species data will be available or new data will be available, and all can be recalculated easily because it's all automatic.
Thank you, Lola and Miru. I trust Silju is having issues joining us, but we do have another question that is more on the policy aspect of it. The question is there any specific policy currently under development or revision in Liberia that will benefit from this work? If so, how? So I think this is a question perhaps for the team, Mr. Wapo and Miru. I know that you're also working on some policy applications. Please go ahead, both of you, if you would like to expand on this question.
Milo, will you want to start?
Yes, please, Mr. Wapo, if you could start, and perhaps Miru can add a few cents as well.
All right, thanks so very much. You may recall that it was just during this pandemic that the map was endorsed by the government of Liberia sometime May of last year. And it has significantly informed the revision of our NDC. It has significantly informed the revision of our NDC. So that's a policy document for the country that the map have helped us to. And we are also developing key standards that for environmental standards that the stakeholders and the consultants are making reference to the map. And also when the national, the State of the Environment report was being developed, it was the same process that the map was developed. So it significantly informed the consultant and stakeholder, you know, to bring into the State of the Environment report information that were paramount to the formation of the second State of the Environment report and the first National Environmental Action Plan. So we have not gone distance yet, but those are just quite few that I'm informed about, that this process are informed. And as we move forward to the implementation of the project, it becomes more evident and visible of how it will help the country. And even that map showing this to policymaker, it have kind of changed, you know, the mindset of looking at our natural inheritance, the forest, and so forth. Maybe the other colleague can come in.
Yeah, maybe I can just add my experience with the product on informing the revision of the NDCs in Liberia. my colleagues and I are developing a document that actually links the NCA analysis, the natural capital analysis that we are conducting in Liberia with the NDC process, which is quite novel. I don't think there is many studies that have been done like that, but it is novel for us for sure. And we are finding really connections between NCA and NDC across different sectors in Liberia. I can mention, for example, one or two sectors. One of them is energy production. I mean, as we know, Liberia has majority of the energy for cooking and heating and etc. It's coming from wood. Wood is collected, and charcoal. Wood is collected, and charcoal is collected from natural ecosystems and shipped to sort of settlement places and cities. And with the map we developed, we are able to do two things. We are able to see where the deforestation is occurring and degradation as well through the condition account, and we can monitor that from 2000 to 2018 now, and so we know where are these sort of deforestation focus points where some policy needs to be implemented. But on the other hand, we also know where the degraded land is, and therefore the degraded land, for example, could be used for the growing some energy crops, some fast-growing wood energy crops that can be then used for production of charcoal on degraded lands. So therefore, there is a direct link of the map to identify the places good for energy production, etc. And I can go across different sectors, agriculture, forestry sector, of course, a coastal zone sector with the mangroves. Our latest Jeff supported project in the coastal region on NCA is producing valuable information that could then guide and inform policy development in the coastal region. But I'll stop here. I think, yeah, if there are more questions, I can carry on.
Thank you so much, Miro. There are a number of very interesting questions on the chat box. And again, I will try to synthesize those, but please feel also free to hand your hand virtually, and we'll be happy to bring you to unmute you so that you could ask your question. I'm going to combine a few questions here. One of the question is this a novel approach, or was an existing approach that was used to develop those maps? That's question number one. Question number two is how much time it took to do this, and how would it take to replicate in another country? And also how long it took to the government of Liberia to endorse, and also can you elaborate a little bit on the process of endorsement? Perhaps I'll start with that. I'll hand it to Mr. Wapo on the overall process and the endorsement of the map.
Thank you, Rosemary, and thanks for the question. It was a very rigorous process. How long it took me, maybe I can start with that. The development processes started sometime early last year, presented to the government. And the processes to have endorsed were rigorous in that different line administrative agencies, sectorial representation were considered. I remember FDA came up with several issues for clarification, leges, and agriculture and so forth. And these issues had to be clarified, and some adjustments were done. Then finally, there was cross-section of the sector that the final, having had all of the inputs from the sector were presented. And May of last year, so the beginning, some part of last year, it was presented, all of these things were done, inputs were made and considered, questions were raised and clarification were made. And then by May of last year, it was endorsed. So government taking this very paramount as it will help its development program, did not waste time in any way, but took it and made sure that cross-sectorial representation were done. And after that, it was endorsed in May of last year. So it was just relatively short period of time, but consultation was really intense.
Miru and Lola, can you talk about whether this is novel or it's something that it was adapted? Can you talk about the process, both for the land and the ecosystem classes map?
Sure.
Lola, could
Sure.
you want to start, or you want me to?
Sure, I can start. So I think on the ecosystem mapping side, the methodologies we used were not necessarily novel methodologies for land cover mapping. I think what was novel was the fact that we were applying it on the country scale, and that we were using this, at the time, still relatively new software called Google Earth Engine. And so by using essentially these cloud computing platforms to do large-scale data processing, this allowed us to combine several methodologies in one. But I think many of the algorithms and of the methodologies that we were using had been developed previously and have been used since then as well.
And I can add here on that ecosystem type mapping, or modeling rather, we used a software, or rather methodology, developed by our Australian colleagues called generalized dissimilarity modeling, that was actually published sometimes in 2007, but never used, you know, in such a context, natural capital accounting context. And therefore, from that perspective, yes, it was novel to combine these two different approaches to end up with a new product in a way that is useful for natural capital accounting. Yeah.
Thank you, Miru. May I bring Henry? Henry, you're, please, can you unmute yourself? You're allowed to ask your question.
Thank you. Thank you. Do you hear me? Sorry.
Yes, we can.
Perfectly well.
Okay, thank you very much. I am Henry. I am based in Colombia. Thank you everyone for your wonderful presentations. I was very curious about Celio's presentation because he make it look so simple. And of course, I am excited to approach to the technical matters and to really have the opportunity to use these kind of tools. So my question is if everyone, or at least a big group of professionals, really can use these tools as the Google Earth Engine, their statistical package, to build a map, or you have to have a very specific background to work with these tools? Thank you.
Lola, can you take that question with your experience with our Gabonese colleagues?
Sure. And I think Celio's back on too, so maybe the two of us can answer.
Yeah.
You want to go ahead, Celio?
Sure. Yeah. So in terms of background necessary to run that approach, I think the minimum background in remote sensing would be useful for you to understand the intricacies of the method. But the way that is built in this platform essentially allows anyone with any background to essentially run the entire script and potentially achieve the final land cover map. So in terms of background, remote sensing, obviously it's not required, but it would be preferable, but it's not necessary. So the pride that we take in this methodology is that it's easy to replicate, even if you don't have any sort of background in remote sensing, or even in the language used within Google Earth Engine. So, and Miro mentioned about the Gabonese counterparts. Essentially, they came and visit us for a certain period of time, and they did not have any knowledge on programming. They didn't have any knowledge about Google Earth Engine. And by the period of they spent here, they were able to catch everything that they need in terms of the language necessary to run the approach, and they were able to reproduce and create an entire land cover map for Gabon. So we were quite pleased to learn that it is possible. It is replicable for other parts of the African continent, and also considering the fact that they didn't have any background with Google Earth Engine and programming.
So that's a land cover side maps, and on the ecosystem type modeling, you know, it is helpful to have people who understand, you know, biology and statistics as well. So, you know, using the statistical program to do the modeling helps, you know, and also knowing, you know, how the species and the different types of ecosystem could, for example, occur in a certain country. And obviously we've been working with local experts to sort of verify that it is important to have a person that can sort of communicate with the local experts and put things together. And again, running the software, you know, the programs are developed, therefore, you know, rudimentary knowledge of R is probably sufficient.
Thank you, Miro. Sophia, I'd like to do a time check. We are at 9:36, and there's certainly quite a few questions that we can and are happy to continue the discussion. But let me ask you, what's the timeline here for us?
Yeah, so actually the timeline has already passed. But I think it's a super interesting discussion. So, you know, if people can hang on, I think we should. I just want to ask Sanjay if he's available to do the wrap up a little bit in like 5 or 10 minutes, if that's okay, or
yeah, no, that's fine.
Just let Sanjay.
No, I already had to apologize for another meeting because this is so interesting. So I'm going to hang in there for another 10 minutes. Thank you.
Super. Thank you so much.
Thank you. So we are starting wrapping things up. There is a very good question here on the need of the role of a need of in situ data and ground truthing, which speaks for the validation of this type of effort. And so perhaps Miro and Celio can speak on that. There's also a question on how well this approach would work in dry forest landscapes or ecosystems with high level of seasonality. Both are very important questions. And so I hand it over to you.
Maybe I can start with the validation. So we found from our work that the validation process is very important. Yeah, and the ground truthing and involvement of local expert is key to producing a meaningful product, and therefore the development of, for example, a development of robust national forest inventories or other data collection efforts should be considered, you know, to be part of it, part of the integrated into the process of developing such a map. And it will allow basically further validation and refinement of both of land cover and ecosystem extent map. And particularly in Liberia, you know, the government of Liberia have just finished the forest inventory process, and we are hoping to, you know, slowly refine even this product we had, slowly refine the map based on new information and new ground truthing that will be conducting through other NCA projects like the Coastal Project, etc. So it is a sort of a continuous process that we envision into the future. I will hand it to Celio now.
Yeah, I just wanted to build on what Miro just explained. So a good sampling is actually key for a good classification output. So ground truth is by far the best type of samples you can use in any classification approach. And these samples will essentially be used as well to verify the accuracy of the final map. So this process is very, very important of part producing any sort of map with remote sensing. And on the seasonality question, so our approach was designed in a way that we, at this point in time, we are looking at annual land cover maps. However, the approach within Google Earth Engine, it's flexible enough that allow you to shrink or expand the time frame in order to capture the seasonality, and also allows you to add other data sets that might essentially help you detect that seasonality. You can use different vegetation indices that might help you in that. So the approach is not fixed. So it's very flexible, and that allows you to bring different data sets and different type of information. And as I mentioned, shrink the time frame so you can detect the seasonality signal for dry forest, for example.
And I would add that we are now piloting this in sort of a semi-dry and dry environments in Botswana. So that obviously it's a further development of the original algorithm.
Yeah, that's a good example, Miro, in a way that we had to adapt in the sense of bring other data sets and other indices to be able to detect and map those drier environments in Botswana, which is completely different from Liberia. So again, it's very flexible and allows you this bringing this new data sets and different types of indices to capture those different classes.
Thank you so much. Sophia, may I ask you for some of those questions to be perhaps kept and shared with our speakers and panelists, so that we can share answers however we can through the community of practice, perhaps sometimes through WhatsApp or whatever means that we may have to answer those questions. I'd like to ask you everyone to join me in thanking our speakers and panelists. We are, very grateful for you to share your wisdom. Mr. Wapo, Danielle, Celio, Miru, Lola. Thank you very much. We very much appreciate. I now hand it to Mr. Sanjay Srivastava to wrap up our webinar.
Thank you, Rosemary, for doing an excellent job. Really appreciate, and I know I continue to thank the presenters, those who ask questions. I think this is so rich, and it opens up so many doors. So I think I cannot thank enough. So let me, in closing, I think I learned a lot, but let me see the four key points that I think is very important and lessons to take this task further. One is the baseline information. And I think, you really demonstrated that to create a baseline, almost accurate baseline, it's amazing job done by both NASA and CI colleagues along with government of Liberia to create this kind of baseline. And I hope that, we will have some method and mechanisms and systems established to continue updating this baseline map, which is at the core of any decision making. The second key point that came out in terms of tools that are available now with open source tools available to do this kind of analysis, to really use the data and the baseline available. And there are so many tools, and you make it sound, as someone asked, that you make it sound so simple. And this is unbelievable that we have come so far. And I've been in this profession for at least 30 years. And I have not seen that, such information would be available to the frontline people. So I think the fact that, these tools are simple to understand, are not very complex, and so more training, more interaction to really bring this, this knowledge and understanding of tools to do the analysis should be done. And you've done it in Liberia, but we're looking forward to opportunity to do it in many other places in Africa. The third is a point that came out, that all these maps, the beautiful maps and the high resolution 30-meter by 30-meter maps with such updated data and different levels of distinction between various types of ecological assets and services is again incredible development. And I think those maps, while we have developed for Liberia, I think it is very important that we do it for other similar countries. And those were not available to policymakers. Those were not available to a lot of scientists. And I think Liberia has shown the path. And I think we want to learn on how to do it and how to develop a similar maps for other countries, particularly the resource-rich countries, but do not have enough resources to do the ground truthing and to really prepare these maps that can be used by policymakers. But fourth, the last but not the least, is where the rubber hits the road, as we said, that we have all these maps and data available, but how do we inform the policymakers? And I think Dr. Wapo from Liberia demonstrated how it is informing NDC. But I think even going beyond that, and I can tell you from based on the World Bank's engagement in Liberia with big lending in both forestry sector, fishery sector, and other natural resource sector, is that it is indeed informing policy debate. I'm not saying one policy, but it is informing, creating public debate on how should the forest concession be managed, how should the forest asset be managed, even the spatial thing. Where is the go areas and where is no go area for any such concessions? Similarly, on the coastal areas, and how to conserve the wetlands or mangroves. I think this is indeed very, very useful, and I think that is where the true value of such maps are. That it is informing the policymakers, sometimes Ministry of Finance, who take decision in terms of how to develop some of the other areas, or how to conserve it, and how to grow the economy using knowledge about these natural assets. So I think incredibly valuable, and it opens up so many doors and opportunity, and I would want this community of practice to remain engaged. And as Rosemary said, if there are questions, let's take them up, but also keep the community together, and let's continue the discussion and interaction with each other. With that, I think I want to thank you all for very, very good webinar. And Sophia for bringing us all together. So with that, have a lovely rest of the day. Thank you.
Thank you.
Thank you, everyone.
Thank you so much, everyone.
Thank you so much,
It was a
everyone.
fantastic
Thank you. Bye-bye.
webinar.
Okay, have
Thank
a nice
you.
day. Bye-bye.
Everyone.
Bye.